So this video is about drawing Lewis structures. There are different ways to draw Lewis structures, but I find this method to be the simplest and the easiest way to not make any mistakes. And I suggest everybody using this method. So I have broken it down into multiple steps. This is just a guidance, but I'm going to show you an examples how I'm using these steps. So first thing you have to keep in mind is that to start, you have to count the total number of valence electrons because the valence electrons are the ones that they are involved in bonding. Then sometimes the molecule, it's in the form of an ion, so it has a positive or a negative charge. If it has a negative charge, that means there's extra electrons. So you have to add electrons to it. So when you're counting, you add electrons to that. And if it's a positive charge, that means it lost some electrons. So you have to subtract the electrons from that. Then put the central atom in, draw single bonded bonds attached to the central atom, and then start filling up the octet for the outside atoms first. So make the octet satisfied for the outside atoms first, and then later we take care of the central atom. I've made a video that explains the octet rule and some exceptions to it, so I'm going to tag it over here if you want to watch it later. Then if there's any remaining electrons, when you're doing the counting of electrons, then that extra ones can go as a lone pair on the central atom. The last step, which is step 6, is very important. So you want to make sure that every atom in that molecule now is satisfied with the octet. So of course, there's some exceptions like hydrogen, for example, it's happy with 2, but most other atoms are happy with 8 electrons. So you want to make sure you go through that, because if they are not happy, then you have to start making double bonds and triple bonds in some cases. So I'm going to show you this as in some examples right now. So let's say we have NF3. So we count the total number of valence electrons. So nitrogen is in group 5, so it has 5 valence electrons. Fluorine is in group 7, so it has 7, and then times 3. So in total, we have 26 electrons. Then we make 3 single bonds attached to the central atom. So now we keep track of our electrons. We're using 6 electrons right now, so we're still left with 20 electrons. Next step for us was to satisfy the outside atoms. So to do that, that means each fluorine needs to have 3 pairs of electrons, or 3 lone pairs. So 6 electrons goes on the left one, 6 on the right one, and 6 in the bottom. So this way we're using 18 electrons, and we still have 2 electrons left. So any extra electron can go on the central atom as a lone pair. Now, this was the step that I said it's very important to follow. So you want to make sure every atom is satisfied with octet, meaning which having 8 electrons after bonding. So we have to do the check right now. So when we do the check, we see that the fluorine on the left, it's satisfied with 8 electrons after bonding because it has 3 lone pairs, which is 6 electrons plus 2 in the bond. So it's 8 electrons in total. So it's happy. The right one is happy. The bottom one is happy. And then we do the same check for nitrogen, and nitrogen is also happy. It has 8 electrons right now. So we know that the structure is fine, and we did a good job with drawing the structure. So we go to the next one, H2O. So we do the counting of valence electrons, and then we do single bonds attached to the central atom, which is oxygen in this case. So we subtract 4 electrons, and then we have 4 electrons now remaining. So we said we have to start with the outside atoms first, but then since our outside atoms are hydrogen, they're happy with 2 electrons. They cannot take more than 2 electrons. So because of that, any extra electron now has to go on the central atom. So 2 pairs of electrons go on oxygen. So this way we use all 4 electrons as well. So all the electrons in total are used. So now we do the check. Hydrogen is happy, this hydrogen is happy, and the oxygen is happy. So we know our structure is good. Now let's take a look at another example. HF. So we count the valence electrons. We make the single bond between them. We subtract 2 electrons because we're using 2 right now. Then we said we have to put electrons on the outside atoms. Both H and F are outside atoms. So H is happy with whatever it has. It's happy with 2 because it's an exception. So the 6 electrons now go as 3 pairs on fluorine. Now we do the check. And for check, we see hydrogen is good, happy with 2. Fluorine is good, happy with 8 right now. So we're good with this structure. Now we go to the next one, CCl₄. We do the same thing, count the total number of valence electrons, make 4 single bonds attached to the central atom, which is carbon in this case. We subtract 8 electrons because we're using 8 already. So we have 24 left. Now we make the octet happy for the outside atoms first. So each chlorine has to get 3 pairs of electron on it. So if you count all the lone pairs that I put in there, in total, we've used 24 electrons. So we subtract the 24 and there's no electrons left. So nothing can go on carbon anymore. But now we do the check. Chlorines are all good, 8, 8, 8, 8. So everything is good with octet. And then carbon, central carbon is also good because it has 8 electrons after bonding. So the structure is good. Another example, O3. So oxygen each has 6 valence electrons times 3. So we have 18 electrons in total. Single bond O's, we're using 4 electrons in total. We subtracted, we have 14 left. We put the lone pairs on the outside, 3 pairs here, 3 pairs here. So we lost 12 electrons. Now we have 2 more left. Anything extra goes on the central atom. So we have no more electrons left. Now, this is tricky because now if you take a look and you do the check, you see the oxygens on the outside are happy. They're good with 8 electrons, but the oxygen in the center is not. It only has 6 electrons. So this is the time when the central atom is short. That's when you start borrowing from the outside lone pairs, one of the lone pairs from one of the outside oxygens, like this one, you take it out and you make it a double bond shared between the 2 of them. So this way your electron count is not changing. So you still are using all 18 electrons. But if you do the check, you will see this oxygen is good. The central one is now good, has 8 electrons, and the right one is good. So now we know this is the structure that we have to get in order to satisfy the octet. Let's look at Cn minus. So we do the same thing. We count the valence electrons. Just one thing is that there is a charge of -1. So that means there's an additional electron. So you want to make sure you add that 1 electron to the whole structure. So in total, we have 10 valence electrons. We do a single line between them, subtract 2. Now we have 8 electrons. So 8 electrons have to start going on the outside atoms, which in this case, both of them are on the outside. So it doesn't matter which one you start with. I suggest starting with N just because N is more electronegative. So maybe it's better to start with it, but really doesn't matter in this case. Just make sure you satisfy one of them with octet before putting the extra electrons on the other one. So I put 3 pairs of electrons on nitrogen and then the other 2 on the carbon. And then this way I've lost all the electrons. So now it's time to do the check. Nitrogen is good. It has 8 electrons, but then carbon, it's not. Carbon only has 4 electrons. So to fix this issue, what we have to do is, again, start borrowing from nitrogen and make a double bond between nitrogen and carbon. So we make a double bond. Now, if you look at carbon, carbon now has 6 electrons. So it's a tiny bit better, but still not there yet. So this way, this time you have to take another pair out of nitrogen and make it shared between them again. So now carbon has 8 electrons, so it's happy, and nitrogen has 8 electrons, so it's happy. So the structure is good. And then when your structure has a charge, when the molecule is in the form of an ion and it has a charge, you have to put a bracket and you have to put the charge on the outside. 2 more examples before we end this video. So CO₃²-, same thing. We count all the valence electrons, 24 in total. Make 3 single bonds. Keep track of electrons. We have 18 left. Put 3 pairs on each oxygen. Now we lost all our 18 electrons. Now it's time for check. This is good. This oxygen is good. This oxygen is good. Carbon is not good. That's, again, the time to start borrowing from the outside atoms. Get a lone pair from there and making double bonds if needed. So what we do is we take one of the lone pairs out. We make a double bond. And now we do the check. Oxygen is good. This is good. Central atom is good, and this is good. And so we know our structure is good. And then we put the bracket with the charge on the outside. And then last example, CO₂. We do the same thing, count the electrons, make the single bonds, subtract 4, 12 electrons. So we make the outside ones happy. Put all the lone pairs on the outside. All the electrons are used now. We do the check. This is good. This is good. This carbon is not good. So to satisfy that, we have to borrow a lone pair from this oxygen, make a double bond. And then carbon now has 6, still needs another 2. So we take another one out from the other oxygen, make another double bond. And now when we do the check, we see everything is good. This oxygen is good. Carbon is good, happy with 8. And the oxygen on the right is good as well. All right, so that was it for this video. Thanks for watching. Make sure to subscribe for more and feel free to ask any questions if you have in the comments section. I'd love to hear from you. Have a good one.